Hello guys, you are welcome. My name is Dr. Kingsley. Okay, in this class I'll be taking you on chemistry, organic chemistry, and we are looking at what? The preparation of ethers. That is how ether can be prepared. Now I'll give you 2 to 3 methods by which ether can be prepared. Now the first one that I'll be taking is Williamson ether synthesis. This is the best method through which ether can be prepared. Williamson of University College, London, in 1850 devised this method. What is it? It is a reaction between alkoxide and the alkyl halide, to give us what? Ether. Now oxide is RANA. This is a sodium alkoxide. Sodium is best for this reaction. Now reacting with alkyl halide. This is a alkyl halide. When two of them react, what we are going to get, we can call this one R prime, for the alkyl halide, and R for the what? Alkoxide. Now when they react, we will be having R prime, right? Plus NaCl. So this is what? Ether that is obtained. So if we have CH3ONA reacting with CH3CH2, Cl, of course. Now this will give us CH3O, then we have what? CH2CH3 plus NaCl. So that will be the compound. This is what? This is an ether. Now what's the name of this ether? Remember, ethers are named as what? As alkoxy-alkane. So this is what? Methoxy-ethane. Remember, I have done a class on nomenclature of ethers. So remember, you can go to look for the video, to learn more about the nomenclature of ether. Now this reaction normally takes place in the presence of alkanol. Let's say we might use ethanol. Ethanol. So it will require a solvent, which is alkanol. So ethanol. So that is one method through which ether can be prepared. Then the second method through which ether can be prepared is what? Reaction between alkanol, but the alkanol have to be excess alkanol, and conc H2SO4. So reaction between excess alkanol and conc H2SO4 will give us ether at temperature, temperature of 130 degrees Celsius and below 130 degrees Celsius and below. So the temperature have to be around 130 degrees Celsius and below. Now how do we get that reaction? Now we have what? Alkanol, like CH3 CH2OH. This is alkanol reacting with conc H2SO4. Remember, the alkanol should be in what? In excess of the acid. Then at a temperature of about 130 degrees. So if we balance the reaction, we put 2 here. 2. So that what we'll be having is what? CH3, CH2O, CH2, CH3 plus H2O. So that is the equation. So you have a ether and what? Water. This is a diethyl ether, which is ethoxy ethane. So we can have 2 CH3 OH reacting with a conc H2 SO4. So we'll be having 130 degrees Celsius. We'll be having CH3O, CH3, plus H2O. So that is the compound that will be obtained. So remember that in this reaction, that our ethanol must be in excess of the acid. So the acid should be what? Limited. So limited acid and excess ethanol. Remember at what? A low temperature, 130 degrees Celsius and below. If you take ethanol CH3, CH2OH, if you take ethanol to be limited, and you take what? Acid H2SO4 to be in excess, and the temperature becomes high, 170 degrees Celsius, you are not going to get what? Ether. You will get what? You will get, in this case, alkane. So what you have here is will be CH2 double bond CH what? 2. Remember, when ethanol is in excess, acid is limited, you get ether. But if the ethanol is limited, while acid is in excess at a higher temperature, you are going to get what? The alkanes. So that is another method through which the alkanes can be, ethers can be obtained. Now if we want to get cyclic ether, we get cyclic ether by intermolecular Williamson ether synthesis. Now if we have CH2, CH2, OH, and we have what? Cl here. Sorry, let me extend because we need 3 carbon atoms. So CH2 OH, minimum of 3 carbon atoms. This is Cl. Now this Cl, chlorine can what? Can leave this compound. When chlorine leaves, this oxygen will come here to attack. Now what will happen is that we will be having what? We will be having CH2, CH2, CH2. Here will be oxygen. They share this oxygen plus what? Plus the chlorine and the hydrogen that leaves here will give you HCl. Then this compound will rearrange itself, to give us this. So this is what? This is an ether, cyclopropane. That is a cyclic ether. Please subscribe to my channel, like and share my video. Your liking will help me. Thank you.